show the grading, then I can't tell whether or not you actually did or not. Okay, so number 28, here we are grading. Their work is sufficient, except there are a couple things that I'd be worried if you just wrote this that you didn't understand. First of all, you guys see their delta x work in the sense of there was the area or the region from 3 to 1. So A would have been 1, B would have been 3. They say cut it into n equals 8 subintervals. That's why we're going by a fourths. And if we're going by a fourths, this is good, but it's too much of a jump for some of you. What I would have liked to have seen in your work is these sleeves don't look very much. This is kind of annoying. Sorry, because I'm tall, I have longish arms, and so then sleeves. Anybody else have that problem? They like hit you in weird places. Okay. Same thing with pants, but that's okay. So coming back, we have 1 to 3, and we're counting by fourths. Did anybody have trouble counting by fourths? No? I totally would have hated counting by fourths. I would have been so annoyed. No one was annoyed by counting by fourths? Oh, you didn't do this one. How do you count by fourths? I would say that's 4 fourths, right? Couldn't we just do 5 fourths and 6 fourths, which you could reduce? 7 fourths, right? 8 fourths, 9 fourths, 10 fourths, 11 fourths, and then what's 12 fourths? Okay, because you also do decimals. Yeah. So what would decimals have been? 1.25, 1.5, 1.75, 2, 2.25, 2.5, 2.753, right? Yeah. That works too. And what do we have to do with each of these little guys?
Multiply by
plug them in. Plug them in, right? Yeah. So couldn't we technically, now if you were allowed to use your calculator, which is when you were, theoretically, if you were allowed to use your calculator, couldn't you have done the following? Ready? Couldn't you have done now I'm just going to show, don't worry, I'm not going to show all 8, right? The A8. Let's just get a pattern real quick. What are the bases of each of them? 1/4, right? And then F of, and then 1/4, right? And then F of, and then 1/4. What's going to be true for all of them? 1/4 and F of, right? Okay. So why did the book say pull the 1/4 out?
Because they typed them all.
That way you don't have to write it every single time. The 1/4 is the base for all of them because they're equally spaced. So they just pulled the 1/4 out. That saves time, number 1. Number 2, what do we plug in for the left? Which endpoints?
1 to 11 fourths.
1 to 11 fourths. So 1 and 1.25 and 1.5 and 1.75, etc., 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 all the way down till you get to 2.75. Why isn't it going to hit 3? Because 2.75 forms the height for the last rectangle, right? Yeah. And the 2.75 height goes over to the 3, and we're done. We're at 3. What's going to be different for the right? This is the left. What's going to be different for the right?
Just change A1 to change A1 to 3.
Yeah, exactly. You could just, if you want, you could go 2 different ways. You could say, hey, I'm going to start at 1/4 F of 1.25. You could do that. 1.25, 1.5, 1.75, any at 3. Or you could do my trick of working backwards. of 3, and then 1/4 times F of 2.75 until you get all the way back till 1.25, because the 1.25 will establish the height for the rectangle that goes and hits that 1. Okay, how could you use your calculator to make this so much simpler besides pulling out 1/4?
Yes, so you can plug it. You can plug the function into your y1.
You can plug your function into y1, and then?
And then you can do a full, but then you can go up, press enter, and it brings it down, and you can change. Let's say if you did the left first. You can change the 1 to a 3.
Nice. So what Sean is saying is use function notation. If you have that function in your y1, like we've seen many times, on your home screen, do 1/4 times, right? And then do y1 of 1 plus y1 of 1.25 plus y1 of 1.5 plus y1 of all the way to y1 of 2.75, solve. And then for the right, just second enter or go up and grab it and then just change it and say, oh, let me take out the 1 and let me put in a 3. Done. Or you could be really snazzy in 3 and 2.75 and 2.5, etc. But you could just take out the 1 and say, nope, I don't want the 1 anymore. I want the 3 and all the rest of them. And then you would be able to solve. So can we use our calculator if we're allowed to? Yes. But do I need to see some sort of representation, whether it's this or whether it's just 1/4 times this guy plus that guy plus that guy plus that guy? You don't have to have it all nice and pretty and plugged in necessarily, but I do need you guys to know how to solve it by yourselves by hand. Does that make sense? Now question, why is the actual area between these two?
Because it's an upper and lower bound. Yeah.
This is going to be an under approximation. That's how the AP would say it. This is going to be an under approximation. This is going to be an over approximation. Why? Well, because you guys see the empty space under, right? Or see the extra space over. So therefore, the actual area is in between. Good. Number 36. Number 36. Let me clear off this ink. Do you guys see how they're plugging in?
Yeah, you know.
And they showed this time, they showed the base times height for every single one, and that they showed the 1/5, 1/5, 1/5, 1/5, 1/5. But do you also see how you could have just pulled it out? Okay, so pull out the common base of 1/5, and then what are all of these?
Those are
The height for the first, and the second, and the third, and the fourth, and the fifth, right? Which once again you could have done your calculator. But this one might have been one they had you do by hand. Where would you have boxed it? If it was a
right
line
there.
Yeah.
When you had the F's.
Oh,
No,
yeah.
no. Not when you had the F notation, but when you plugged into F.
Okay.
As soon as you have to have numerical representation. What that means is no notation. No notation. This isn't notation. This just needs to be simplified. Something has been plugged in. But if you were to, for instance, if you were to box it with the 1/5 times F of, I don't know the details. Was it F of 1?
Oh, so
Yeah, that would be one.
F of 1? If you stopped here, they couldn't give you full points because it wasn't just a numerical simplification that was needed. You don't need to numerically simplify, but you do need a numerical expression. Does that make sense? The numbers in there, not just the notation. So this would have been good to write, but you would have had to plug in some way, shape, or form. But you can box here and say, yeah, I'm done. Good try.
That'd be up to 0. Sorry.
Oh, F of 0, that makes more sense because it's 1 minus 0.
Yeah.
Okay. I couldn't figure out exactly what the function was. I didn't take time to. Because it's 1 minus x squared. Okay. Anyway, there we go. Final answer, if you guys did solve it out to check to make sure you did it right, would have been 0.859. But if you solved it, it would have been 1/5 pulled out, f of 0 plus f of 0.2 or f of 1/5 plus f of 0.4 or f of 2/5 plus f of 3/5 plus f of 4/5. This must have been a left-hand one, right?
yes, that was from the left.
Okay, and from the left, it would have been an over approximation. How do you guys know that? Did they say that?
It was from the graph.
Okay. So are you guys getting in the homework, were you able to visualize if I hit at the left and go over, it's going to either protrude out or it's going to leave a little bit off the over and under?
Yeah.
Okay, good. So then the right-hand one was the under, right?
Mhm.
And the under one, you would start at 1/5, or you could say start at 1 and count backwards. So it's plugging in 1, you would have had 0, plugging in 4/5, 3/5, 2/5, 1/5. Don't go to 1. I know we had 0.659. Number 68.
Yes.
Okay, what was going on in number 68? They give you a function, they give you an A and B, and they give you an N, true?
Yes.
Okay, now they're showing all sorts of crazy notation up here,
Yes.
right? They're giving you all sorts of crazy notation. But the long story short of it is that they gave you the particular values to use in your rectangles. They gave you the values, the x values to use in your rectangles. This is similar to if they're giving you something like a table. Did they only give you these ones?
They didn't give us
They
these.
didn't give us these.
You gotta solve for it.
Yeah.
Did just
So
say
you can
that.
Did they say midpoint?
Yeah.
Oh, that makes more sense. Okay. Sometimes they give C's, it must be in the correct one, I was gonna tell. Anyway, they said midpoint. So, for instance, if they were to give you, go ahead and show it anyway. If they were to give you a table, they could have done 0, 1/4, 1/2. What was my N?
4.
Okay, so if we were to do,
Does like a midpoint give you a better approximation or something? Because it just seems like a huge waste of time.
didn't you see yesterday? The actual integral was 18, and it gave us 18.25, whereas the other one gave us 22, and the other one gave us 13.
Oh, wouldn't it depend on each function?
Depend on the nature of the function. Because if we're doing rectangle approximations with a linear function, well, actually the midpoint would be perfect then. If we were doing midpoint approximations of a constant function, what would be true about all of our rectangles?
Everything.
It'd all be perfect. The midpoint and the
Yeah.
left and the right would all be the exact same as just me finding the area of a rectangle.
But it would still be slower than this thing, you know.
Well, that one it would be. If I was to use my number line kiddos, if I'm going from 0 to 2, and if I'm going n equals 4, I'd say, okay, 1, 2, 3, 4. There are my subintervals on my number line. 0 to a half to 1, 1 to 3 halves, 3 halves to 2. But was I allowed to use 0 or a half?
No,
Why are they using a fourth?
because it's the midpoint.
Because it's the midpoint. So I'm using a fourth and 3/4 and 5/4 and 7/4. I could have made a number line. I'm trying to show it to you in a table because the AP loves to put these questions with numerical data, aka they don't give you a function at all. They give you a table instead, and you have to use the table. So if we're going from 0 to 2, we're going by jumps of 4, so we go by every other. The in-betweens would be the midpoint, so what we'd be using for our heights. Can we make the change in base equal? So, b minus a, right? All over 4. My delta x is 1/2, which they show there. b minus a over 4, my delta x is 1/2. So I could, for my area expression, let me show you what's going on here. I could say, hey, it's 1/2 times everybody, right? Like we did with the 1/4 just a second ago, pull them out, or the 1/5, pull them out. So pull out the 1/2. And then what am I going to use for my f ofs? F of
1/4,
1/4 plus f of
3/4.
3/4 plus f of 5/4.
If they give you a table and they have to give you an end,
If they give you a table, they have to tell you in the table where to start, where to end, and they have to tell you whether left or right or midpoint. And they have to give you some sort of number of jumps. So they could say from 0 to 1 by jumps of 4 using a left-hand approximation. Then you would use f of 0, f of a fourth, f of a half, f of 3/4.
and then you would just, because it'd be an x, y, so y.
You would plug in the y's, right? These would be the f of x values. This tells you, hey, what am I using? This also tells you the base by the jumps, because if they give you a table, almost always it won't be equally spaced. So like this would be a half, this would maybe be like 3/4, this would maybe be like 2, this would maybe be like 5. So you have to like actually make, that's why I show the A1, A2, because then you actually have to show the different bases times the different y values. Yeah. But guys, since you can use your calculator, couldn't you have done the y1 trick and then just done one nice line of your calculator?
Yeah.
Good, and the final answer ends up being 8.171. 8.171. Okay, you'll definitely see this stuff more, you'll definitely see tables as well. I think in section 4.3 it might come back just a little bit. But the title for section 4.3 is Riemann sums and definite integrals. Ooh, look at this snazzy thing.
Finally.
It looks like a limit of a summation and oh, it's an integral. Anyway, let's go. Notes open. Limassol? That's so different. Yeah, but Limassol is so different.
That's what it looks like to me. I don't know.
But it's not.
Because it has like a C with a little squiggly Portuguese C thing on it.
A squiggly Portuguese.
No, I know it's like French, but doesn't matter.
Something weird is going on. What's weird?
That's not
I got
what
lost.
I heard corky cheese.
I don't know what you guys are, because that's not what I said.
Sure.
Portuguese. That looks fake though.
Okay, hold on. Something weird's going on. There's something missing.
Why would I say Portuguese?
Because you're obsessed with this.
Because I'm upset. No. You're so confusing. What color should I do this?
Testing. Why is it on my desk? Alright, so as you guys were sketching, oh, it froze again. First of all, geometrically, how do we solve for a definite integral? Or I should say graphically. Let's start there. Graphically, we either solve with geometry, or we approximate with rectangles. Or trapezoids. What? We solve with geometry or we approximate. Why am I saying solve or approximate? Because rectangles and trapezoids are geometry too. I don't get it.
But they may not fit what we're, because
Ex-
geometry would be
you
exact,
know,
but they might not fit exactly what we're going for.
So we can either solve exactly sometimes with geometry, or we can always at least approximate. Okay? Solving with geometry, solving outright, not just approximations. That's what A, B, and C are for. So letter A, first of all, if we were to graph this function, y equals 4, what would it look like? Yeah, a horizontal line, right? A horizontal line at y equals 4. And then if it says the bounds are 1 to 3, can you guys see that area? How would we find it?
You think a square?
It might be a square.
Or you just multiply the base.
It's at least a rectangle, so base times height, right? So then what's my base?
Times 2 from that.
2. My base is 2 and my height is 4. So all I have to do is say, oh, a base of 2 and a height of 4, and this is a perfect rectangle, so therefore this equals 8. Dun, 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 dun. It's a rectangle, 2 times 4. How about letter B? What is he?
It's a circle.
It's a circle.
It anyway. It's the top half. Let me see.
No, not letter C. Sorry, letter B. Didn't I say B? Letter B. He's a linear function with an intercept at 2. True. And a slope of positive 1. Oh, struggle. Then let's go ahead and move that down. And let's make these tick marks a little different. Aha. So that's 2. There we go. And that's 4. Okay. So you go up 1 over 1. Up 1 over 1.
Oh dear.
Up 1 over 1.
It seems to be curving.
Stop judging. From 0 to 3. Could we say that's a rectangle plus a triangle?
Yeah.
Of course we could. Or we could also be super snazzy and review geometry for a second and say, wait a minute, it's a trapezoid. It's a trapezoid with a base of 3, a height 1 of 2, and a height 2 of
4.
5. I think, right?
Oh yeah, you're
3 plus 2 is 5. Sorry, I didn't put the last tick mark. What is the area formula for a trapezoid? For a rectangle, area is just equal base times height. For a trapezoid,
1/2 height times base 1 plus base 2.
except on this one, 1/2 the constant is base, and the different heights are height 1 plus height 2. So add the two heights, 7, average it, 7 halves, times 3 would be 21 halves. If you were to put this integral into your calculator, it is exactly 21 halves. 10.5. Now, Tyler, letter C. Who is he?
That's a semicircle.
It's a semicircle with a radius of?
2.
Because we added to our forever card r squared minus x squared yesterday, right?
Right.
So it's a semicircle with a radius of 2. There is no other way that you could possibly solve this area this year. Even next year, it would be a struggle. Meaning, you have to be able to recognize this guy to be a semicircle. Now hold on, careful. What bounds?
-2.
Okay, so it's the full semicircle. If it was 0 to 2, what portion of the circle? It would have been a quarter circle. Good. For a semicircle, what's my area formula?
Pi r squared and then 1/2 times.
1/2 pi r squared. So therefore, I could go ahead and put in my 2. That's my radius, right? So 2 squared is 4. 4 divided by 2 is 2. And 2 times pi is 2 pi. Approximated, we could use left, right, or midpoint Riemann sums from last section. Did you guys see the word Riemann in any of homework?
Yeah, I think so.
For approximating, that means if we don't just have linear or circular boundaries for the curves that we talked about yesterday, we could use the left, right, or midpoint Riemann sums. However, there is another way to approximate. Oh, sorry, lo siento. We can also use trapezoids. And that's where we're going to end today. Trapezoids. You might think trapezoids are the same as midpoints. They're not. Oops, wrong one. Trapezoids. This is technically one of the better approximation techniques. Now remember, once again, all of these techniques, when the limit as the number of rectangles approach infinity, they're all going to converge, stabilize, approach the actual area. So we wouldn't have to use a more crazy area formula, like the area of trapezoids, if we're trying to find the exact of the limit. But if we were just trying to approximate, trapezoids are a pretty good technique. What we're going to use is, once again, if we're making the base, that's going to be our delta x. Our heights, once again, are going to be f of x values. But what's going to be different for each partition, for example, for this one, we would use A for this partition equals 1/2 of x2 minus x1, or you could say delta x, that's the base, times f of x1 plus f of x2. We're going to use both heights. Left just uses the left, right just uses the right. Midpoint says, let me find the average or the in-between. Trapezoid says, I need both. So like for the one that we did yesterday, at 0, we'd hit, and at 1, we'd hit, and we'd connect. Do you guys see how this is going to be a better approximation? At 2, we connect, and then at 3, we connect. And it's going to skim the curve better. With that, kiddos, we are done. It is a chapel day. You can start homework. Definitely not finished. It's not due until Thursday. Riemann sums and definite integrals, you definitely have the tools to start. But tomorrow I'm going to make those trapezoids a little bit prettier, but you guys have the idea.
Misty,
Yeah.
is use of the next integration technique we do?
Yeah.
Like, okay, where is
Well,
that?
no, we do STC first. But then we'll come back to the antiderivatives and use them. Because we haven't technically solved a definite integral, you guys just solve one yesterday.
Okay, well, can you direct me to where you sub is?
4-4, I think.
4-4?
Were you here yesterday? I was. Did I miss anything? No, that's not perfect.
Ooh, it might be actually after the next test, though. Is it 4 or 5?
We're correcting.
It's 4-4 or 4-5. You'll find it. Next Thursday, I hope.
I don't like tests. I feel like homework is like
I know the tests get confusing. I'll make sure you guys get the practice test early. Okay.
Jackie.